Hello students, this is Shiv Bhadra Singh from Hygia Institute of Pharmaceutical Education, and in continuation to my previous lecture of structure of benzene, today we are going to discuss about the same, that is the structure of benzene depending upon the modern theories of resonance and molecular orbital structure of benzene. So, a regular work for the derivation of a structure of benzene is going on, and in 28th century, keeping in mind the structure of Huckel of benzene, scientists try to find out a center of symmetry in the structure of benzene by using various spectroscopic methods. These methods include various analytical methods like X-ray diffraction, IR spectroscopy, Raman spectroscopy, UV spectroscopy, NMR spectroscopy, etc. As I have already discussed in my previous lecture, X-ray diffraction is a technique in which X-rays are used to find out various diffraction patterns of the structure, and this diffraction pattern will help to determine the structure of compound. IR and Raman spectroscopy both are the techniques in which we determine vibrational modes of molecules to provide a structural fingerprint by which molecules can be identified. UV spectroscopy is a technique in which electronic transitions are used to determine the number of unsaturation present in the compound. NMR spectroscopy is also known as nuclear magnetic resonance, in which radio waves and magnetic field is used to determine the number of hydrogen and carbon present in the structure. And by using all these processes, it was proved that there is no center of symmetry in the structure of benzene, and hence Huckel regular hexagonal structure is wrong, as benzene does not appear to have any center of symmetry in the structure. So, by further investigation using liquid benzene occurs, and it was concluded that the overlapping vibrations and intermolecular forces distorted the equilibrium of benzene into two resonating structures which destroy the center of symmetry in the structure. Coming to the resonance description of benzene, resonance is a phenomenon in which two or more structures can be written for a substance which involve identical position of atoms, and the actual structure of the molecule is said to be a resonance hybrid of various possible alternative structures. According to the resonance theory of organic molecules, benzene exists in two resonating structure as it is visible in the figure. Structure A and structure B are the two resonating structure of benzene, and having a resonance hybrid of structure C, which can be shown by these two figures. And according to this theory, carbon-carbon bond in the benzene are neither single bond nor double bonds. Rather, they are something halfway between, and this is exactly what we find out experimentally. Coming to the molecular orbital structure of benzene, The structure of benzene is best described in terms of the modern molecular orbital theory, and according to this theory, all 6 carbon atoms in the benzene are sp2 hybridized to form sigma bonds, which are shown in the figure. Since the sigma bonds results from the overlap of planar sp2 orbitals, all carbon and hydrogen atom in benzene lie in the same plane. Also, each carbon atom in benzene possesses an unhybridized p orbital containing 1 electron. These p orbitals are perpendicular to the plane of sigma bonds, and the lateral overlap of these p orbitals produces a pi molecular orbital containing 6 electrons. These 6 electrons of p orbitals are said to be delocalized, and this delocalization results in more stable molecules of benzene. These 6 electron clouds are also called as aromatic sixlet. So, these are the two different modern theories, that is the resonance theory and the molecular orbital theory for the structure of benzene. In the next lecture, we will discuss about the Huckel's rule. Thank you so much for listening the lecture.